research, I'm working on information extraction from product labels. So Penn State Abington is a smaller campus. Penn State University have around 24 campuses. So ours is almost a third largest campus at Penn State. So we have 4,000 students, and everyone are undergraduate. So we don't have a graduate program over there. So, making the students to work with research projects is a kind of a challenging thing. So I used to talk to all the students and brainstorm a few ideas. So one time I was talking to one of the students, and she told me that she has a grandmother who's almost like 85, and she has trouble in taking the pills on time. So because she can't read the pill labels properly. So we thought about it. So we thought, okay, let's develop a system where she can capture a video, and the system is going to come back and say all the details about the pill label. And so we thought, okay, let's work on this idea and develop this for other product labels as well. So that's the research topic I'm going to talk today. So generally, you have a product label, the extracting those is going to be very important, because you want to see if more details about the ingredients, nutritional facts, and usage instruction. If you have any dietary constraints, you want to see all the information from these labels, right? So if I want to automate this process, we want to extract all this information accurately, and it's also essential for regulatory compliance and overall the integrity of the entire, the market chain. So we want to develop a system which can be more accurate and as well as cost efficient in automating this entire process. All right. So I'm just going to give you an overview of the entire system today. So entire system. All right. I request all the others to mute their computer. All right. Thank you so much. Okay. So we're going to start with the data acquisition, collecting the data. So we can manually collect the data and feed that to the system, or we can automate the process by having a camera system, which captures the video and convert those into images. And once we have those images, we can process those images. Basic image processing, there's tons of open sources available nowadays to perform the image processing. So once we process those images, and then we can extract the text from those images. OCR is a common approach to extract the text. OCR is Optical Character Recognition. So we extract the text using OCR techniques. And once we extract the text, now the next step is to extract the information by using a natural language processing techniques. So once we have those information, now we can query the entire system. Whatever information you want to see what are the directions for usage, or is there any any warning signs and so on. So so that's what we did. We developed a model, we trained the system, and we queried the system to give us whatever results we need. All right. So the most challenging thing, if you look at this, is after we collect the data. First of all, the data collection itself is a big deal, especially if I want to collect the data from the pill bottles. These data are not available because of few constraints. Nobody wants to share their medication information. So what we did is we went to the off the counter. We collected a few pill bottles, and we had around 200 pill bottle images. We manually collected those, and then we kind of tested on it. And once we accomplished it, and then we worked on the other different product labels. So when you take a pill bottle, and if you capture the video, when you rotate the pill bottle, right? So it's a cylindrical pill bottle, right? So extracting the images correctly from the cylindrical pill bottle is kind of a challenge. So we cut all those images, and then we applied a dewarping technique to make those images a little bit, and then we stitched those images, and then we performed a template alignment to match the template what we have. And then we started extracting the information. So I'm going to go over those processes one by one. Okay. So these are the few challenges to extract this information. Most of the product label, the formats are different. They're very diverse. Okay. We cannot have one system to fit all those product labels. So we have to somehow categorize those product labels and develop, and apply our technique on those. And the product labels have different languages. Some of the product labels might be vertical, some of them might be horizontal, some might be, in a different approach as well. So we require a robust model to handle all this multilingual and multimodal data. Other challenges we have is the ambiguity in the text information and abbreviations. So we need to decode those abbreviations. Some abbreviations might have multiple meanings. So we need to understand the context of the product as well, so that we can extract a relevant, information. And also we have to abide with the regulatory standards. So that's more important. So these are some of the challenges. And extracting the information, we need to find where the critical data is. So locating the critical data is also very important. And when you capture the images, we have to make sure that we're capturing at right angle and the lightning. All right. Okay. And we also have to make sure that our system works for different shapes of labels and different product containers. Structured text versus free flow text, that's also a challenging one. Okay. So if you have a structured text, for example, if anything says that warning, colon, and it has some information, now it's a little easy to decode those information. Whereas if you have a free flow text, now we have to apply more techniques on it and then extract the information. So that's pretty challenging. Regular rectangular labels are fine. So if I have a square in a product, and if you have a label on top of it, it's a little easy to work on. For example, let's say if I have a mobile phone, and if anything is written on the mobile phone, now I can just capture the image and extract those information. But if I have, let's say, a Tylenol or a sauce bottle, now if I have to extract the information, I have to rotate that bottle so that I can capture all the images, okay? I can capture all the video and then take all those images, and then I have to stitch those images to extract the information. So that's kind of challenging. Okay, so I'm going to give you an overview of all the techniques what we applied. So initially, once we capture those images, we applied, computer vision techniques, which basically it's image processing. Okay, so we applied various image processing techniques to find out where the information is. So our most challenging is the location of those information. So once we find the location of those information, then we can apply OCR techniques to convert the images to text so that we can decode those messages. Okay. Right. So once we extract the information, the text from the labels, now we can apply natural language processing. Natural language processing is a field of artificial intelligence which focuses on interaction between the computers and the human. Okay. Right. So basically, when we talk about natural language processing, there are two different kinds of process. One is understanding the information. So the system, what we develop, the mission has to understand our natural language. So that is natural language understanding. So once it understands our natural language, we can decode those information, perform all the processing. And once it finds, finds some results through those process, now it has to generate some information or generate a message so that we can understand those information. So that is natural language generation. Okay. So in our approach, we did the same thing. So we make sure that the machine can understand the label informations. So once it extracts all the information, once it processes it, and then we generate messages so that we can understand what the machine is trying to say. Okay. Right. Okay. And then we apply some machine learning algorithms so that we can predict those information, we can classify those information. So I'm not going to dive into too much details about the overview of the machine learning models. So basically, if I have to give you a little bit of information about machine learning, so we have supervised and unsupervised learning models to recognize the patterns in the product labels so that we can get more accurate information from the labels. Okay. So how to extract the information? So the challenging part is finding the key points. Okay. So we developed few techniques. Okay. So we developed convolutional neural network to identify the key points of these labels. So if you look at this particular image, we have detected the 6 different key points, right? So once we have the detected key points, now we can capture those images. We can extract only those information. Okay? And we applied a dewarping technique. Okay? So where we can, if you look at the image, the third image over here, right? So over here, so it's kind of cylindrical, right? So we want to make it a rectangular shape, okay? So flat image, so that once we apply our OCR, it's easy to detect all those text. Okay, so we applied a dewarping technique, we extracted those information, and we did the same thing for all the images. So once we have all the images dewarped, now we can stitch those images together. Finally, we will get one flat image. So once we have this final image over here, now we can apply different template on those images and extract the information. Okay. So for example, CVS Pharmacy has its own template. Walgreens have its own template. Every pharmacy might have its own template. Okay. So we need to somehow detect which pharmacy it is so that we can apply the template. Okay. So what we did is, as I said, we collected around 200 to 300 pill bottle labels. We manually collected those because those informations were not available online. We collected almost 400 general product images. Okay. And we annotated those images, and then we applied our DCNN, deep convolutional neural network on it, and extracted those information. We also worked on the EfficientNet, which is also a CNN, Convolutional Neural Network, and to localize these 6 bounding key points based on the predicted heat maps, so that once we have those key points, now we can extract those information. We also tried around 10 different key points. So 10 different key points, that also worked well for our approach. So once we have those key points, now we can apply the dewarping technique and to extract the information, and then we can stitch those images together to obtain a complete rectangular image. Okay. So I'm not going to give you more, basic details about the CNN. So in short, most of us know about this ANN, artificial neural network. So we're going to have an input layer, have multiple hidden layers and output layer. The CNN is is actually it's based on how the animals view their cortexes. Okay, so they have 3 different layers. So they have a separate layer for red component, green component, and the blue component. So CNN is based on that, and deep CNN and efficient net, all those are advanced of CNN. Okay. All right. Okay. So we applied the dewarping technique, and we extracted those rectangular image after we stitched all those images. Now we're going to apply our template. Okay, so once you match the template with the key points here, so now we can extract more information. For example, if I want to get the information about the quantity or when the refill is, I can get that. Okay, or if I want to find out who was the doctor who prescribed it, I can find that. Okay, so the 80-year-old grandma, if she wants to find out what pill tablet is this and how many tablets she has to take, how many pills she has to take every day, she can get all those information. Okay, so that's what we did. Okay. We also tested that on the off-counter products. For example, this is an eye drops. Okay, so here it's the challenging in the off products is identifying the template. Okay, pill labels, pill bottles might have a standard template, but there are 10,000s, maybe millions of products out there, so we can't have a template matching for all the products. Okay. So what we did is, instead of focusing on the logo and other parts, we focused only on the text information here for the other products. Okay. So what we did, we applied our OCR technique. So our OCR technique, what we, instead of applying a traditional OCR, so we applied an OCR coupled with RCNN, okay, recurring convolutional neural network, and we extracted the text. So once we extracted the text, now we started decoding. Okay, so what are the keywords we are looking for? For example, most of the products might have a common signature like uses or warnings or active ingredients, so on. Okay, so we are looking for those keywords. Once we extract those keywords, now we can extract all the relevant information. Okay, so we applied on a commercial product. This is a deodorant, okay, deodorant stick. So we applied on that as well, and we extracted those information, and we compared it with our, our OCR approach with other online approach, and we could able to extract more information. Still, there is a lot of challenging things because there's plenty of different products there, and the font size, the color, the font style, all those are pretty challenging. And the way you take the images on those products, that's also very challenging. If you not taking in a right angle, you're not going to get those information properly. Right. But we tested on different products, for example, dairy products, beverages, medication, skincare, grocery labels, and so on. Okay, so we almost tested on close to 400 different product labels. Okay. So our system worked pretty well. To find those key points, we have an accuracy of around 85%. Okay, so we could able to detect the key points properly. So once that's the pretty challenging thing. So once you detect the key points, now extracting, applying OCR on top of it, that's not pretty challenging because there's a plenty of OCR techniques available commercially, right? So we could able to achieve around 85 to 86% of extracting those information. And we also tested on the commercially product labels. So that's very challenging since we worked on almost like 400 different labels. Sometimes the accuracy is pretty good. Right. So currently it's around 48%, but we're still applying more. Yes, thank you. So we're still working on to increase the accuracy. in conclusion, this is an ongoing problem. So, everyone are working on it, especially the pharmacy companies are more interested in these kind of applications because it's going to be very beneficial. In future, all you need, most of us have a smartphone. Everyone uses mobile. So all you need is a camera system to just capture those images or the video, and then the system can decode all the information and it's going to tell you the relevant information what you want. Okay. So and some more future directions on how to apply on this research is we can have a robot to automate the system. Okay. So something where the industry does, they automate the system to detect some imperfections on the products. Okay. So now if, on an higher scale, if I want to find out if there is any imperfections on this product labels, okay. So now we can develop a robotic system to identify those information. So we can have those products lined up on the conveyor belt, and then we can have a robotic arm to pick those products and rotate those products in front of a camera, where the camera can capture all those information. Just to show you a little bit of video. So something like this. So we want to integrate that with this robotic, project so that we can, extract those information automatically. That's one idea what we have. So the challenging part is how to pick up those products. So once you pick up the products and then you rotate it in front of the camera, now you have all those images, and then we can apply our image processing techniques to, to get those information. And then we can label it either it is a defective product or it's, it's approved for the production. Okay. So the other area is we are also working on developing our own robot. Okay, so that the robot can help the elders. Okay, so all they need is if they show the product in front of the robot, now the robot can capture those images. We have a Raspberry Pi which can process those information, and then it can, spit out whatever relevant information. So we didn't buy this one, so we developed on our own. So we have this body chases, and we added all the relevant sensors to this robot so that it can function. You see, you have this ultrasound sensor, and there are a couple of cameras. Okay, so cameras in the front, there's camera in the back as well. So now what our idea is to have to raise the camera on the robot probably around 3 feet high, so that you don't need to bend down to show the product images. You can just show it when you're sitting or standing at that position itself. And so we kind of tested this robot to move on different surfaces. So hard surface is pretty good. It can able to move. And we also tested the robot on the carpet, because sometimes making the robot to move on the carpet is pretty challenging. So this product, we're still developing it. So, once it's developed, right now it can see, it can hear, it can also talk, okay? And any objects, it can avoid those objects and move on, okay? So we are still working more on this robot. This work, we work with different students, and some of the students, they already graduated, and we want to continue working on this area because it's this AI, as everyone knows, it's pretty hot right now. So everyone wants to work on this in artificial intelligence. So hopefully we would try to take it to the next level. Right. Any questions? Sure.
This is David Weissman. So you bring up some interesting innovation and applications here. with AI and the ability to identify the pill itself, possibly with your future work, is there any way to use your OCR to make sure that the pill inside the container matches the container? And have you thought about that for LBs?
That's pretty interesting. So we haven't thought about that for now because, when we examined 200 different pill bottles, most of the pills are of different shape and size, okay? And they are color coded, but there are few pills which are in the same size and in the same color as well. But if you carefully zoom in and look at it, you might have some information on the pill itself, a small line or something embedded on the pill itself. So we haven't got to that point yet because now the challenging thing is how are we going to make the 80-year-old person to hold the pill to capture image properly? So that is very challenging. So we are still working on it. We thought about it and we thought, okay, let's target one thing at a time. So now if we know that all the pills in the pill bottles are correctly labeled, okay, how can we make an old person to organize those into the pill organizer, taking the pills and organizing in the pill organizer. We always do that. So, if you go to CVS or Walgreens, they have this pill organizer for 7 days, morning, evening, and all those things. So my mom does that too. She takes a pill at a time, she organizes all the pills for a week. So now the challenging thing is she taking the right pill from the right bottle? So we want to target that person. Once that is working, and then we want to see whether the pills are correctly labeled or not. All right. Any other questions from audience? All right. Thank you so much.